Solubility product. What do you understand from that? If I say you have a saturated solution, I hope you understand that a solution in which no more solute can be dissolved is known as saturated solution. Unsaturated solution is a solution in which more solute can be dissolved, and a supersaturated solution is the one in which no more solute can be dissolved. If we add on, it settles down at the bottom, that means precipitation occurs, right? So how we are going to chemically understand that? So let us understand there is a equilibrium constant called as solubility product. So what is solubility product? Solubility product is calculated for a saturated solution, and what is it? It is equals to ionic product. Let me explain you with an example. If I take, let's say, I have an electrolyte AB, right? It ionizes in a solution, it ionizes, electrolyte AB ionizes to give A plus and B minus. So what will be the solubility product for this? Will be Ksp. Solubility product is represented by Ksp, and this will be equal to concentration of A plus ions into concentration of B minus ions. Alright, and what is ionic product? Ionic product is also written as Kip, and that is also equals to A plus and B minus. So what is the difference? Solubility product is for a saturated solution, for saturated solution only. For saturated solution, the ionic product is equals to solubility product. For unsaturated solution, what are the condition? For unsaturated solution, ionic product is greater than, I'll explain it again. Solubility product equals to ionic product for a saturated solution. Saturated solution, a solution in which no more solute can be dissolved, is known as saturated solution. For saturated solution, solubility product is equals to ionic product. Next, if Ksp is greater than ionic product, such solution is known as unsaturated solution, right? And what is a solution which is known as supersaturated solution? What is the condition for precipitation? Condition for precipitation is that ionic product has to be greater than Ksp. So a maximum capacity of a solution to hold ions is understood by solubility product. So this is the maximum condition, right? So if ionic product is lesser than Ksp, that means more ions can be present in a solution. Because of that, we get unsaturated solution, but precipitation occurs when ionic product becomes higher than the maximum value. Ksp you can understand. If I give you a physical meaning, you just understand that Ksp tells us the maximum limit of a solution. So if ionic product is lesser than that, that means more ions can be present, that means more solute could be dissolved. If ionic product is greater than the maximum limit, that means precipitation has to happen. So for precipitation, the condition is ionic product should be greater than Ksp. So this is the condition for precipitation. Alright. So how we write ionic product, or how we write Ksp or solubility product? So I'll explain it here. I take an example A2B3. So how it ionizes is 2A3 plus and 3B minus 2. Now Ksp is written as, if you want to write in terms of concentration, how you are going to write is A plus 3 raised to the power of its coefficient, that is 2, and B minus 3 2 raised to the power of its coefficient, that is 3. So this is the formula of solubility product written in terms of concentration of ions at equilibrium. Concentration of ions at equilibrium, right? And this is also equals to ionic product at equilibrium. This is the condition for equilibrium. This is the condition for equilibrium. So if this product is equals to KSP, that means we are at equilibrium. If this product is less than KSP, we have an unsaturated solution. If this product is greater than KSP, that means we have precipitation condition. So this product is basically nothing but ionic product. So KSP is a constant value. Ionic product depends on how much solute has been dissolved. If KSP is the maximum value, if ionic product is less, you dissolve more up to KSP. If more ions have been dissolved, it will come down by precipitation up to a KSP. KSP is a temperature dependent value. It does not vary on putting some common ions or putting a complex forming agent. So KSP remains same if the temperature is same. Alright. But what happens to solubility? Solubility will decrease if you put some extra common ions. Alright. So common ions decrease solubility of an electrolyte. So more the solubility, more will be the amount of dissolved state of that electrolyte. Some salts are more soluble, some salts are less soluble. We have different categories of salts: salt of a strong acid and strong base, salt of a strong acid, weak base, and salt of a weak acid, strong base, or salt of weak acid, weak base. So how we dissolve salts? We add salt to a water, to a given quantity of water, then salt hydrolysis occurs. When you dissolve salt into water, salt hydrolysis occurs. This is a reverse phenomena of neutralization. Acid reacts with base to give salt and water, and reverse is salt and water react to give acid and base. So salt hydrolysis is basically reverse of neutralization. That will be a helpful idea for you to remember. Alright. So we have different categories of salts which I told you. For example, if you have NaCl, so NaCl is formed by a strong base called NaOH and a strong acid HCl. NaOH reacts with HCl to give you NaCl. Similarly, if I take a weak acid, for example carbonic acid H2CO3, and a strong base NaOH, what is the salt name you get? I think you guessed it right. You carbonic acid and NaOH react to give sodium carbonate. So similarly we can form salts of different categories. So that's it for now.